Okay, guys, this is Madhukar again. Continuing on with the lecture on binomial distribution, we shall now derive the expression for the mean and the expression for the variance and standard deviation of this distribution. So, again, I am writing down the definition of the binomial distribution. Px of x, or instead of that, I can write in another notation also. Different authors use different notations. B of x, semicolon, n comma p. It means B means binomial, x means x is the random variable, discrete random variable here. N is the total number of outcomes, P is the probability of success. So that's what he has written. Instead of writing this, you can write down as Px of x, not an issue. Px of x is equal to ncx, p to the power of x into 1 minus p whole to the power of n minus x. So this is nothing but the probability of having x successes corresponding to a series of n independent trials, and the probability of success in any one of the trials is p. That's why I told you that probability of success is p, probability of failure is 1 minus p or q. Okay. Now, the mean value is simply given by expected value of x. If you remember the previous theory class before this lockdown was imposed, we had written down the formula for the expected value of a random variable in the previous class, in the classes that was held in the college, and also in one of the classes that I had held online using Zoom before I started to record these video lectures. Right, I had discussed about the expectation value also. How do you define an expectation operator? How it is linear? Or how do you define the expected value for a discrete random variable? How do you define the expectation value for a continuous random variable? Those and all we had discussed. So using the same criteria here. Now, the first order expectation or the first order moment, first order expectation of a random variable gives me the mean of the random variable. The first order expectation of a random variable, the first order expectation of a random variable gives me the first order expectation of a random variable gives me the mean or average of that particular random variable. Okay. Now I am going to take the expected value of this random variable. So E of x, since it is a discrete random variable, I have to use the summation. So E of x is simply given by summation x is equal to 0 to n x into px of x. Let me write down that. So E of x is given as, since there are n independent variables, independent trials I mean to say, so x into summation x is equal to 0 to n x, this is x, okay, x into px of x. So E of x, this is a bracket, okay, expect E of x is simply given by summation x is equal to 0 to n x into px of x. Now what is that I am going to do? Substitute the value of px of x into this formula. So px of x is the nothing but the definition of the binomial distribution. It is simply given by ncx p to the power of x into 1 minus p whole to the power of n minus x. So px of x is simply given by ncx p to the power of x into 1 minus p whole to the power of n minus x. So this becomes summation x is equal to 0 to n. So if I substitute the definition of px of x, this is what I get. So I just repeated. To recapitulate, E of x is given by summation x is equal to 0 to n x into px of x. This is the standard formula for the mean. E of x gives me the mean. E of x squared is something else that we shall discuss while we compute the variance. So E of x is simply given by summation x is equal to 0 to n x into px of x, or summation x is equal to 0 to n x into ncx p to the power of x into 1 minus p whole to the power of n minus x. Now substitute ncx. ncx is simply given by x into factorial n divided by factorial x into factorial n minus x into p to the power of x into 1 minus p whole to the power of n minus x. Here I have not done anything additional new. I have written the formula for ncx. ncx is given by factorial n by factorial x into factorial n minus x. That's what I have written there. That's all. Now, if I now try to expand this summation, this can be written as the value of this entire thing at x is equal to 0 plus summation x is equal to 1 to n, the value of this terms. Let me repeat, split this summation by substituting x is equal to 0 plus after x is equal to 0, next integer should come, right? So the next integer after 0 is 1. So integer 0 plus the value of this terms when x is equal to 0 plus summation x is equal to 1 to n, these terms, that is factorial n by factorial x minus 1 into factorial n minus x into p to the power of x into 1 minus p whole to the power of n minus x. x is equal to 0 substitute ಮಾಡ್ತೀನಿ ನಾನು. ಅದಾದ್ಮೇಲೆ ಪ್ಲಸ್ x is equal next term ಯಾವುದು, summation x is equal to 1 to n, the same terms. Now if I substitute x is equal to 0, 0 into this entire term is 0. 0 into anything is 0. So that's why there is no contribution from that value x is equal to 0. That's why I get only summation x is equal to 1 to n only. I get summation x is equal to 1 to n only. Now let me do a substitution here. Just a minute, let me erase this. I am erasing only what that I have written. Now let me substitute let me put x minus 1 is equal to y. If I put x minus 1 is equal to y, also let me substitute m is equal to n minus 1. Let me substitute this substitution. Let y be equal to x minus 1 and let m be equal to n minus 1. Now when I do the substitution y is equal to x minus 1, I can also write for x is equal to y plus 1. And when I am going to substitute m is equal to n minus 1, when I am going to substitute m is equal to n minus 1, I can write for n as n is equal to m plus 1 into the last sum, right? This substitution is very, very important. I am substituting y is equal to x minus 1. I am substituting y is equal to x minus 1. And also, I am also doing another substitution, namely, I am putting m is equal to n minus 1. You may ask, sir, I don't have m here. So what I am going to do? Put m is equal to n minus 1, solve for n. So n would be equal to m plus 1. So it would be as if I am substituting y is equal to x minus 1 and substituting n is equal to m plus 1. So now, since I am doing the substitution, there would be a change in the values of the summation also. So when x is equal to 1, I have y is equal to 0, and when x is equal to n, I have y is equal to n minus 1. N minus 1 is nothing but m due to the second substitution that I have done. Please note, I have done two substitutions, y is equal to x minus 1 and m is equal to n minus 1. Now, having done the substitution y is equal to x minus 1, I can also have x is equal to y plus 1. Now, m is equal to n minus 1 means I can also write n is equal to m plus 1 by transposing minus 1 to the left hand side. Now, because of the substitution, there will be a change in the values of the summations also. So when x is equal to 1, I have y is equal to 1 minus 1 equal to 0. Now, when I am having x is equal to n, then y is equal to x minus 1 equal to n minus 1. But n minus 1 by another substitution is equal to m. So the new summation values would be summation y is equal to 0 to m. So I have n is equal to m plus 1. So m plus 1 factorial divided by x minus 1. I have substituted x minus 1 is equal to y. So I have y factorial. N minus x is equal to m minus y factorial. Okay, because of the two substitutions. Okay, n is equal to m plus 1. Okay, and x is equal to y minus 1. So plus 1 minus 1 gets cancelled, and in the denominator here I am having m minus y factorial into p to the power of x I had previously. So x is equal to y plus 1. So that's why p to the power of x gets replaced by p to the power of y plus 1 here. 1 minus p whole to the power of n minus x. So n is getting replaced by m plus 1, and x is getting replaced by y plus 1. So plus 1 minus 1 gets cancelled, and this n minus x gets replaced by m minus y. It's just algebraic manipulation. Okay, next. I hope this step is clear. Okay, next. You see the substitutions here. So there would be plus 1 and minus 1 cancellation, and there would be a direct relationship between y and m directly putting here. The same story applies for the factorial terms here and also for the other power terms here. So now m plus 1 can be written as, now apply the formula that we discussed in the previous video. So factorial x can be written as x factorial of x minus 1. Now treat x to be equal to m plus 1, just assume. So factorial of m plus 1 can be written as m plus 1 factorial of m plus 1 minus 1, which is equal to m plus 1 into factorial m. ನಾನು m plus 1 factorial na split ಮಾಡ್ತಾ ಇದ್ದೀನಿ. So m plus 1 factorial, treat m plus 1 to be some variable, say z. So z factorial z can be written as z into factorial z minus 1, isn't it? So z is equal to, I put z is equal to m plus 1. So it is equal to z factorial of z minus 1. So z is equal to m plus 1. So factorial z equal to factorial m plus 1 would be equal to z factorial of z minus 1. So m plus 1 factorial of m plus 1 minus 1. 1 minus 1 gets cancelled, and I have left with m plus 1 into factorial m. But m plus 1 is a constant, because of course factorial m is also a constant, right? So m plus 1 is a constant, so I can pull it outside the summation. So that's what I have pulled it outside. Now p to the power of y plus 1 I have. P to the power of y plus 1 can be written as p to the power of y into p. P to the power of y into p. So that's why that p I am taking outside the summation. P to the power of y I am keeping inside the summation, because p to the power of y is a dependent variable, p is a constant. So that's why p I am pulling it outside. 1 minus p whole to the power of m minus 1, m minus y I am going to keep as it is. M plus 1 factorial can be written as m plus 1 into factorial of m plus 1 minus 1, which gives me m plus 1 into factorial m. M plus 1 is a constant, I have pulled it outside. Factorial m I am keeping it inside. P to the power of y plus 1 can be written as p to the power of y into p. P to the power of y into p, yeah. P I am pulling it outside along with m plus 1. P to the power of y I am keeping it inside. Other things remain as it is. Now this becomes np, and what is this m plus 1? What is this m plus 1? This m plus 1, please look at the substitution that we did before. M plus 1 is nothing but equal to n. M plus 1 is equal to n. Please look at the cursor. M plus 1 is equal to n. So I get np summation y is equal to 0 to m factorial by factorial y into m minus y factorial into p to the power of y into 1 minus p whole to the power of m minus y. Now, by binomial theorem, this is simply written as, compare this with the binomial theorem. So a plus b whole to the power of m is simply given by summation y is equal to 0 to m factorial m by factorial y into m minus y factorial into a to the power of y into b to the power of m minus y. So only thing is that a is equal to p and b is equal to 1 minus p here. A is equal to p and b is equal to 1 minus p here. So this is nothing but np into 1 plus p minus p whole to the power of m. So a plus b. So since a is equal to p and b is equal to 1 minus p here, this is simply coming to a plus b whole to the power of m, or it is equal to p plus 1 minus p whole to the power of m, which is equal to 1. So it means that this entire summation evaluates to 1. this entire summation multiplied by NP, this entire summation evaluates to 1 because A is equal to P and B is equal to 1 minus P. So A plus B whole to the power of M. So A is equal to P, B is equal to 1 minus P. So P plus 1 or 1 plus P minus P, P minus P gets cancelled. I am left with 1 to the power of M, which is equal to 1. So this entire summation evaluates to 1, leaving behind NP. So NP into the summation is NP into 1, which is equal to NP, which is the mean or average of this binomial distribution. Thank you.